Using our new encoding of objects, we can continue changing our Mo interpreter to an object-oriented style. And we needed the new capability because value is next, and with value it turns out there are two different operations we care about for values. One of them is inside of numOp, where we find out that we have an int v, and in that case we need to get a number out of the int v. So getting a number out is one operation that we need on values. So number op that takes no arguments and just gives us an integer back for the number. The other operation that we need on values turns out to be here in applications, where we find out that we have a close v, and in that case we want to interpret the body of the closure. That is, we want to apply the value. So let's say apply is our other argument, operation. In that case we need an argument for the value that we are applying to, and then we return a value for the result of apply. So you see we have different numbers of arguments in these two different operations and different kinds of result values. It also turns out that each variant actually does something useful only for one of the two operations, but the consistent object-oriented style is to implement all of these methods on all of the different variants. So our new type for value is going to be a list of tuples where we have a symbol mapping the tuple, mapping the operation name to a function that takes, well, we don't know exactly, something and returns something. It depends on the particular symbol. Then we can implement an int v constructor, which takes an integer, and it needs to return a list of these tuples. So a list of an implementation of the number operation, which is a function of no arguments, and also a tuple for apply that has a function that takes the argument value and implements that. We'll do the same thing for close v. It's a constructor that returns these two lists, number and apply with an argument. Okay, so let's implement the different operations. In the case of a number operation on an int v, we just return the n. In the case of apply, then we have an error from apply that is not a function. So we can't apply an int v, and we do that by implementing its operation to return an error. Similar sort of error for trying to get the number from a function. On the other hand, when we apply a function, that means that we can start evaluating the body, that is, call the body, in an extended environment where we bind the name, argument name. Let's call this argval to distinguish it, the argument value, in the closures environment. And that implements apply. So using these new representations, we ought to be able to run things. Let's see, I missed a closer there. I have misspelled extendiv. And now here in our application form now, instead of matching on the value, we take this result from interpret and we want to find its apply operation and then pass along the argument value to for that. So all of the implementation of application has moved into the apply method. Well, we're going to need to get find. Let's worry about that later. The other place we need to change is where after interp we have our operations. So here the code we want is effectively this code. We want to create an int v with the operation, but now instead of intv.in, then we ask the L object for its number method and call that. And similarly for the right, we look up the number method on the right and call that. I still need to get find, and also it would be better to use that macro abbreviation, so I can just call L.number here and R.number here, and so on for the other places. So instead of making all those changes, we'll just jump to where I have it already done once. We have our find implementation, we have that macro, we have our two objects, and you can see I'm using body.interp now because I've changed all of my expressions also over to this style. And so everything is converted over here, and the parse tests are harder to work with because now I get functions back from parse that I can't easily compare. And the interp tests, I need to extract the number out from all the different ones to get those numbers out. But with those adjustments, then we can convert the whole interpreter this way.